Very good morning, everybody. So you are joining to the Learn workshop of Tuning Up Campus Network. Let me go through the initial proceedings before we start the program. So we have almost about 75 registrants in the participant list. So at the moment, 38 to 39 people have connected. So during the time others might connect, until that, so we can go for the initial proceedings. Let me invite Head of Learn, Professor Rosan Ragel, to welcome all of you. Professor, over to you.
And good morning, everyone. So the idea of this workshop is on, like it's already mentioned by Engineer Herath, it's on tuning up campus network. From Learn, as you are aware, for those who are new as well, we are conducting such workshops for the last several years. In the last years, we are at least having 3 workshops each year, targeting capacity development for engineers in the trade community, our member institutions. So even last couple of years, we had a similar workshop, but with some improvements. We are coming up with this workshop for this year again on tuning up campus network. And particularly during this period, as most of you are aware, we are having a number of issues related to the way how our systems, particularly more than the network, are managed. Vulnerabilities are left out and so on. So we are getting a lot of concerns about those. So I hope you will take this opportunity, this workshop, to discuss such aspects as well, in addition to learning new things from our resource pool, who are very well experienced in conducting such workshops for a very long time. So you will get a lot of inputs from our team. At the same time, please feel free to share your experience, share how you are doing best practices in your campuses, so that each other you can learn from each other and do better. And as a team, as a group of engineers from the Learn member institutions, we can do better. So while thanking Engineer Herath and his team for setting up this workshop and accommodating about 75 participants for this time, that's a really good achievement, and we hope I wish you all a good and successful workshop. Thank you. Engineer Herath, over to you.
Thank you, Professor Ragel. Thank you for your time. So let's start with the program. So event page, you can find the event page at Learn website. And so under the news item or under the training 2022. So you can find the event page. You can find all the detail about the workshop or the agenda, list of participants, everything on this page. So if you just go to the end of the page and click on this is the event page. So the participant list is here. So if you have registered for this workshop, your name should be there. Then the other detail like agenda and the program overview is here. So as mentioned in this page, so workshop is about tuning up campus network. So we have done campus network design workshop few years ago. So this is with some improvement and new stuff came out during that time. Workshop targeting the network administrators in Learn Member Campus. So specifically, this workshop is targeting new people, not the most experienced people. I mean, if you have 3-4 years more than that, so this is not going to help, because those people already have participated in even our previous workshop and also has learned a lot and gained a lot of experience during their career and so on. So this is targeting most of the new people during last few years to train about how you can do the campus network stuff, designing campus network and configuring and placing equipment, deciding what to use and what not to use, and all these kind of things going to be discussed under this workshop during 4 days. So we will have 4 days workshop targeting junior system network engineers, and also we have allowed to join if they needed the teachers of this field who can gain some out of this workshop, especially practical things, lab works, and they can get a lot of thing out of this lab sessions, how they can set up a lab for their students and all that kind of thing. So that is going to be useful. Therefore, we targeting the teachers as well. This is actually new things we consider in this type, other than the network system engineers of Learn Member Institute. So let me introduce our team, my team. So, they will introduce themselves when they are going to talk to you. Myself, Sanavi Herat, Network System Manager for Learn. Then Mr. Dhammika Lalantha, Network System Engineer for Learn. And also Geethika Jayasinghe recently joined. Deepthi Gunasekara, Tuan, and also Dusmantha Vijayanayaka. So this is my team. So at the same time, other people of the Learn administrative and operational people of the Learn support in this workshop. Let me tell you what you have to get prepared for the workshop. This is in red. You need to have a laptop personal computer with Windows 8 or 10 with at least minimum of 8 GB RAM and 20 GB free disk space, especially this for doing the setting up the lab in your laptop. So that is, lab is going to be completely virtualized using real image of routers, switches, and OSs. Therefore, you need to have a reasonably good performing computer. So that is why 8 GB RAM, at least 8 GB RAM. And also you are required to ask to install VirtualBox for virtualizing, creating a virtualizing environment. That is from your side. If you move to the agenda, so we have 4 days. For each day, we have 2 sessions. That is the morning session and the afternoon session. Morning session is start at 9:30 to 12 p.m. Then after the lunch break, so we will have the afternoon session 1:30 to 4 p.m. So altogether, we are going to have 8 sessions. So you are expected to participate in all the sessions. So attendance, we have to take the attendance. So also we have planned to give you a printed certificate, so which will be sent after the workshop or the post or some means. That is about successfully completion of this particular workshop. So there is a requirement from Learn side that you participate, you prove your attendance over the online Zoom for all the 8 sessions. So that has to be keep in mind. So if you have something very critical and some official stuff, so you have to tell our organization team that you want to get out of this particular session. So considering the reason, so they might consider that. So that is how it is going. So day one, we will be discussing about campus network basics. Basically, this is the theory behind the networking, specifically about network equipment, devices, that is switches and routers, and also network cabling, their standards, what should you use and what should you not use during this period. Then about IP addressing, IPv6, IPv4 and v6, and then layer 2 stuff like VLAN trunking, then layer 3 stuff like routing and routing protocols. So that is what we are targeting on the first day. Also, we are expected to, if we have time, if we can finish up this theory part early, we are going to give you the instructions, basically giving you the instruction how you can set up the virtualized lab environment in your laptop. Then the second day, we are focusing on the lab works. During the lab, what we are going to do is we will use Cisco virtualized environment, that is Dynamics and Dynagen, that is what you know as DNS3. Using that Dynamics virtual environment, we will tell you how you can set up such an environment in your laptop or in your computer. So what are the softwares needed, what are the file and images needed, and how you can configure the virtual network in your laptop or a computer in your lab. So then we will give you a sample network, sample campus network, which include almost everything you should have in a campus network. That is layer 2 stuff, layer 3 stuff, and hierarchically structured network, and all that. So that network, you will get that sample network with all the details of VLAN detail, IP addressing, IP address detail, everything. So where you have to set up and configure the given network in your virtualized Cisco lab environment. So once you set up the network, you will configure the network using the command line configuration tools. You will have to configure the complete network and realize that network is up and running. Even though this is going to be a virtualized, it actually works like real network. So you can connect computers into the virtualized network. You can see how you can browse the internet from your LAN site, your campus site. You can also access the network stuff, servers connected to the network from internet as well. So even though it is virtualized, it will work almost exactly as the real network. So that is we have planned on the day second. So day third, if we don't have time to complete the lab stuff in the day second, so we can still use almost half session to complete the lab setup, network stuff of the campus network. Then the fourth sessions of the third day, we will discuss how you can set up, we will discuss about the firewall that is needed to reflect your private IP, specifically IPv4, into the internet using kind of firewall setup where we are going to discuss about PFSense, that is pre-open source, very reliable, very popular firewall. Then at the last day, so we will discuss about how you can configure. We will discuss about simple network management protocol, which is SNMP, where you can use it for your network monitoring and management. So you will be configuring SNMP in your virtualized network devices. Then you will set up a network monitoring tool. There are many network monitoring tools, commercialized tools, and also free open source tools. Out of free open source, LibreMains we are going to set up in your laptop as a virtual machine to monitor the entire network. So that will help you to understand how its SNMP work, how that can be used to monitor network without manual interaction. So LibreMains monitor the network, and it will tell you the complete picture of the network in a particular time. So that is in the first session. So in the last sessions, we will give you some tips about network troubleshooting, how you can troubleshoot if something happened to the network. That is basically how you can figure out the issues in the networks, performance issues, reliability issues, and some misconfiguration issues and all that. So we will discuss during the last session of the at the network troubleshooting. So during the time, therefore, you can click on this online feedback form and give your ideas about the workshops, your feelings, your experience, and all that. There's another link called Instructor Availability. This is actually for you to use during the lab. You will get interface like this. We have recently developed this setup. During the lab, if you stuck in a point so where you need to get help from one of us, so this is the place you can find these instructors. So you can just look at who is available. Then you can just click on this available button. So then you will be connected to this personal Zoom meeting room. So you can have a private session with the instructor to discuss or look at your lab trouble. That is instructor availability. So that is hope that will going to be useful for you to find out an instructor who is free in that moment. So then finally the certificate giving, that is not going to be happen after the workshop. So we will send the all the successfully completed people who you can route and send the certificate to the people over the post. So let me check the number of participants at this moment. It is 53. It is better if you can go for quick self-introductions for all of us. Instructor will be introduce themselves when they're going to present their sessions. So let me invite you to introduce yourself. Meanwhile, before that, I would like to turn on all of your cameras so that we can have a screenshot shoot of all the people who has joined to the workshop in this mode. Deepthi, are you in the session? Deepthi? Deepthi Otuan?
Yes.
Can you take a couple of screen of shoot of this whole participant? window. Maybe a couple of pages there. Appreciate if you can turn on your camera so that we can have a screenshot of all the participants. This is a group photo, so we cannot take a group photo anyway. Keep your camera on for at least 5 minutes so that my team get a couple of screenshots.
Mr. Hirat, can you stop sharing, screen sharing?
Sure, I will do that. I did. All right. All right, we can see a lot of people. So still there are some people who have said to turn on the camera. Yeah, many people are coming. So while keeping the camera turned on, shall we start introducing yourself one after another? So turn on your microphone and introduce yourself.
Okay, I took the screenshot.
Shall we start from somewhere? I'm not going to. Otherwise, we can do what we can do is you can visit this page. I will put that into a chat window. This is the participant page, so we can start from the beginning. All of you can browse this page and start from the beginning. So I'm not going to read the names. Deepthi, can you help me to read this participant list so that the people can then start introducing themselves?
Okay.
We will go through the list. So after that, so if anyone remaining, so we will allow them to introduce themselves.
Let me
Start from the beginning.
can you repeat that?
Deepthi, what I want you to do is you can start reading the name list one by one. Then participants can introduce once you announce the name.
Okay, here the participant list.
Announce the name, wait for some time for him to introduce himself. So if the person is absent, you can go to the next name.
Anuradhi, Abdul Hakim, Abdul Jabbar.
No, Deepthi, I want you to announce the name one by one, allowing them to introduce themselves. Deepthi, did you get my point? Yeah, first name is ACS Anuradhi. If ACS Anuradhi is here, can you please introduce yourself? All right. Okay. Okay, we will move to the second name, Abdul Hakim.
Hello, good morning, everyone. Hello, did you hear
yes,
me?
We can hear you.
Okay,
go ahead.
Okay, my name is Samil. I'm working at Southeast University, Sri Lanka, in Network Operations Center as a ICT technical officer.
Okay, shall I read the name or can you go one by one? I think easy for you to go one by one. So can you please start next one?
Hello.
Yes, we can hear you.
I'm Chamikara Pereira, working as a network manager in Visual Performing Arts University.
Thank you, Chamikara.
Hello, good morning. Good morning. I'm Amila Hera. I'm work at Industrial Technology Institute as a computer system assistant.
Thank you, Amila. Next.
Hello, good morning all. I'm Chamil Kula Singh. I'm working as the system administrator of NSBM Green University, Omalapa.
Thank you.
Hello, good morning. I'm Chaminda Guntilaga from University, attached to ICT Center as the technical officer.
Thank you, Chaminda.
Hello, good morning. I am Charles Chaturanga from University as a system analysis.
Thank you.
Hello. Hello, I am Indula from NSBM Green University. Now, I'm working as the network administrator.
Thank you, Indula.
Hello, good morning. I am Sabidan Vivekanandan. I'm working as a computer programmer at University of Sri Jayawardenapura.
Thank you, Sabidan.
Hello, good morning all. My name is Kanishka Indrajit. I am a technical officer working at Open University of Sri Lanka now.
Thank you, Kanishka.
Good morning, everyone. I am Lakshman Dasanayaka from ATI Candy. I work as IT administrator.
Thank you, Lakshman.
Good morning to all. I am Sumudhu Chaturika from ATI Kurunagala.
Thank you, Chaturika.
So good morning to all. I am Kirabadran, Management Faculty, University of Jaffna, as a network manager.
Thank you, Kirba. We cannot hear you.
Good morning. I am Damayanti Kularatna from the Department of Electrical and Electronic Engineering, working as a senior staff technical officer.
Thank you, Kularatna.
Good morning to all. I am Mohammad Mansur Zahir Hussain from Open University Nawal.
Thank you, Hussain.
I'm Charit Sirivardhana, works at the Open University as a technical officer.
Thank you, Charit. Thank you.
Good morning to you all. I'm Sandhu Fernando from University of California, working as a network manager.
Thank you, Sandhu.
Well, good morning. I am Krishna from University of Jaffna.
Thank you, Krishna.
Hello. Hello, good morning all. I am Kohulan from University of Jaffna as Assistant Network Manager.
Thank you, Kohulan.
Thank you.
I am Arshad from Southeastern University of Sri Lanka, working as Assistant Network Manager.
Thank you, Arshad.
Hello, good morning. I am Shashi Alahatton from ATI Kegol, IT demonstrator.
Thank you, Shashi.
Good morning. I am Varuna Kamage, working as system analyst, University of Ruhuna.
Thank you, Varuna.
Good morning. I am Indika Vijayaratna, National Institute of Social Development. I am working as a computer programmer.
Thank you, Vijay.
Good morning.
Good morning. I am Samira. I am working at Advanced Technical Institute, Kurunegala.
Thank you, Samir.
Good morning. I am Sagar Vikramasekar, working at ITI, working as a senior system administrator.
Thank you, Sagar.
Good morning. I am Rohan from University of Sri Jardhanapura.
Thank you, Rohan.
Hello, good morning. I am Padmasagam, working as a network manager at Faculty of Medicine, University of Jaffna.
Hello, good morning. I'm Mashela from University of Sri Jardhanapura. I'm working as a system analyst.
Good morning. I am Shanaka Idrisingha. I am working as a computer programmer at University of Sri Jardhanapura.
Oh, good morning. I'm Jitter from University of Morocco.
Hello, good morning, all of you. Hello. Good morning, all of you. I am Nipun Sachinda from University of Sri Jardhanapura, working as a computer programmer.
Hello. Good morning, everyone. I am Ramkajiri Surya, University of Sri Jardhanapura, working as a computer programmer.
Okay. Do we have any more people who like to introduce themselves?
Hi, good morning to
all. I'm Divankar, working as a network manager. I'm representing the University of California. Thank you. All.
Thank you, Divankar. Next person.
Good morning, everyone. I am Prabhat from University of Ruhuna, representing ICT Center of the University of Ruhuna. And my team, so I think some of the faculties, they already connected, and some of them are working on some critical issues due to some incidents happened.
Okay.
So they will join soon. So,
Okay.
That's from my.
We shall wait for, so they will join. So we will, anyway, this is record. So we have put the recording so they can review the stuff later once they join, or maybe after during the evening. So thank you, Prabha. Next.
Good morning, all. I'm Inosha Krishantha from University of California. I work as a network administrator or the network manager for the university.
Thank you, Inosha.
Good morning. I'm Darshana.
Go ahead, Darshana.
I am Darshana from Faculty of Medicine, University of Ruhuna. I'm a program of the Faculty of Medicine.
Thank you, Darshan. Any more?
Hello. Good morning. I am Udaya Pushpakumara, working as System Administrator at Institute of Vocational Technology, Ratmana.
Thank you, Pushpakumara.
Hello. I am Taranga from Open University, working as the Assistant Network Manager.
Thank you, Taranga. Any more? Okay, I think it is better if we can introduce the our team as well, because so you have to talk to them during the labs specifically. So let me invite my team to introduce themselves, starting from Dhammika. Hello, Dhammika.
I love it.
Yeah. Dhammika, can you start introducing yourself and the rest of the team?
Okay. And I'm Dhammika Lalantha, working as a senior network system engineer at Learn. I'm working for around 3 years here, and I have previously worked in Institute of Peradeniya as engineer for around 3 years, and so that's myself.
Thank you, Lalantha. Dushmanta, can you introduce yourself?
Hello, I'm Dushmanta. I'm working as
Okay, thank you. We saw your face. How about Deepthi?
Hi, I am Deepthi. I am working as thank you.
Next one, Geetika.
Good morning, everyone. I'm Geetika Jayasinghe. I'm currently working as a network engineer at Learn. Thank you very much.
Thank you, Jitter. Tuan.
Hi everyone and good morning. I'm Tuan. I'm working as assistant engineer at LAN.
Okay, thank you everybody. So we can now move to the sessions. So let me invite for the first presentation, that is about network theory, to the Dhammika Lalanta. Lalanta, you can start the presentation. Oh, the quality. Go on.
Hello, sorry for technical difficulties and delays. I hope you can see my screen.
And can you put that into full screen mode?
This is to remain in my laptop was stuck, and this is another colleague's laptop.
Yeah, that is full screen. Thank you.
Today, in this session, I hope to discuss about campus network basics, very basic things. Some basic and intermediate person would like to know about. And here I will to discuss about network design goals, why we should design a network, otherwise just connecting device and use it. And about cabling.
Hi guys. The thing is that we're having some technical issues from our side, so please be patient with that. At the meantime, guys, you can go through the agenda, and so we are in the first session, and yeah, even from the slides also you can download it and you can view through it. So in here, mostly we are going to talk about the campus basics networks. So as in the first slide, so we can see the network design course until Lalanta is preparing with his technical issues. I'm going to present the presentation for a while. And so in the first slide, there will be, you can see the network design goals and the performance, bandwidth, throughput, latency, jitter, packet loss. And those are the main things that we have to think about when designing a network, mostly the performance and also the reliability and resiliency. Service outages, highly reliable and available network that can survive during any network component failure without any operation intervention. So those things you have to consider when designing a network. And from the next slide, you can see the when talk about the security, guarantee of confidentiality, integrity, and authenticity. Those things, three things are the main thing we have to consider about when consider about network designs. And the traffic isolations between traffic, guest, and internal stuff. And also, I think Lalanta is okay with his technical side. Lalanta. Okay.
Thank you.
Right, Lalanta, you go ahead.
Sorry guys, again that happened. Today we will see into network basics how what should be our network design goals, and we'll see next about network cabling, cat cabling, and fiber optic cabling, and later on we will also discuss on metrics, performance, actually campus metrics about performance metrics and other requirements, and also we'll discuss about how the network design architectures that we should adhere with, and some actually how we should design network and what are the best practices should be. Next we'll see about the services like DHCP, DNS, and how we should configure and place them, and and also we'll see how firewall we place them, firewalls and DMC, and about things like that. So in this slide, so we will be discussing on more basic things, that is for beginners and plus intermediate people. So let's start here. what are actually network design goals. Even we design, when we manufacture something, or maybe car or machinery, we design it. We don't use materials to build it right away. So like when we design, we build a house, we don't use built-in materials to make it right away, but we will design a house with good architecture so that it will be durable, it will be strong. Likewise, it will be beautiful and things. So like that, for a network, we should design it. So why we need design a network? Because we need to fulfill or satisfy the customer requirements. Like there are many customer requirements, mainly normally as in day-to-day internet usage. We normally we talk about speed. Maybe it is whether you are connected to 4G network or home network or campus network. You just talk about speed. We rarely talk about, sometimes we rarely talk about the quality of the network or other metrics. We'll see about some of the metrics when we think about when designing a network. So these are network design objectives. First one is performance. Performance means it has when we talk about performance, we talk about metrics, performance metrics, or some parameters that are used to measure the quality or performance of the internet. First thing is the bandwidth. Bandwidth is actually normally you call the bandwidth actually speed, network speed. But here the bandwidth is think about your network, your university network connection. We provide some 100 Mbps, 200 Mbps, maybe 1000 or 2000 Mbps connections. So that is the bandwidth. Actually, in contrast with throughput, bandwidth is the actual capacity of the network. But even if the capacity is 100 Mbps, due to many reasons, you may not be able to use the full capacity for full 100 Mbps. Maybe you are reaching around 90 or 95 Mbps. So that's the bandwidth metric. So in contrast, throughput is the actual capacity. Sorry, actual network speed when you are connected to internet. So throughput is always maybe always sometimes always less than bandwidth because throughput can't occupy the full bandwidth of the network due to many reasons. Like throughput can be reduced due to many reasons. Due to there may be some latency issues, so some packet loss issues in your network, or some due to think when all of your users are connected to the network same time and try to use YouTube or some bandwidth consuming applications. So network get congested and so that the throughput is vastly reduced and network is indeed unusable. And so that's why throughput is some always less than bandwidth. So throughput is the actual data rate that can be supported by your network hardware. And next metric is the latency. Latency is the thing, the time taken for to transfer a packet from source to the destination. So think when you browse your internet from a remote site, think it get 5 seconds to load the page. So so that's that much of different time can be taken due to the latency. So if the latency is higher, the loading time is large. So we call it then the internet is very slow. So that's caused by mainly the latency. And next thing is the jitter. Jitter is actually the variation in delay. Actually, when we have a session, same or traffic flow, same packets in the same flow can have a different timing. One packet goes faster and one packet goes very slow. With maybe one is going through another route and one packet is going through another route. So the different packets have different timing when it is reaching to destination. So that is called the jitter. Actually, jitter is a very burden, very problem when you are using real-time applications like audio multimedia applications. We need to stream the data in timely manner. If the jitter happens, audio noise or video noise could happen. So that's the jitter. Then the packet loss. Packet loss can happen due to many reasons. One is when the congestion happens. I earlier explained about congestion when all of your network users trying to access the internet at the same time. So when that happens, network links are getting congested because every user is trying to access the internet at the same time. So due to that, packet loss happens, and you actually at that time internet is very unusable. And packet loss also can happen due to some cabling issues, like some cabling faults. So when some cable pairs are damaged in copper cables, it can happen. Also, it can happen due to some hardware issues, or maybe hardware issues and interface hardware issues, and some software issues. Software issues mean routers and switches have, as you know, it has some operating systems firmware. Due to those issues, due to issues in those operating systems, packet loss can happen. Also, due to duplex, full duplex and half duplex things you may have heard. So due to mismatch of duplex from both sides, so for example, one side have full duplex and the other side has half duplex. So due to duplex mismatch, where much of the packet loss can happen. The packet loss is always normally described in percentage. So like 1%, 3%, like thing. So next network design goals or objective we should be careful with is the reliability or resiliency. Network should be always reliable. If it is going to be down always and down and come likewise, and then disconnected of your applications happen and you are very unsatisfied, and also due to that service outages can happen, particularly services hosted within your network or within your campus network. And the resiliency is the quality. Resiliency is the attribute that can automatically actually describes how strong the network. That means whether if something some failure happens, it should be able to automatically recover within within acceptable time frame. And also resilience is some redundancy about the redundancy. If some network connection fails, the other standby or other load balancing network connection should come up and provide the service. So that's about the reliability and resiliency. So network should be always reliable and resilient, and for that we need to implement redundancy at network link level and hardware level. The third the next objective is network security. Security is a concern for maybe users and also for network admins. Network should be able to guarantee the confidentiality of information. That is, information should be isolated and protected by any means, or by password or using encryption. Likewise, so if some sensible information is taken by third party, so we are in risk. So that is an essential objective, that to have confidentiality of the information. And the integrity. Integrity means some people can log into your system and change the information. So changing information is also very risk, because so it can put your information at risk, and you cannot recover the original information and after changing. And next is the authenticity. That is information for the network access should be authenticated, or access to some information should be authenticated. That is, if it is a system, it should be password protected. So authenticity actually verifies that who connects the system and who uses the system. And when using network, we are, as you know, we are using proxy. Proxy actually verifies that the if the proxy can be password protected. So if it is password protected, actually we can verify that actually authenticated users, or if it is in your net campus, the campus users only access your internet. So if you have deployed Wi-Fi within your institute, so Wi-Fi should be password protected, so that so that the people who are looking for the information of breaking your system can't easily connect to your system. And other thing is, when we are talking about the security, we should always try to isolate traffic between the guest and the internal staff. So for that, we are using subnet, right? Subnet and also VLANs. For example, just if you are providing Wi-Fi network for guests, we can put that subnet or VLAN to a different network. So we put so that actually they can't easily see the other important devices like servers and other stuff devices. The other objective or goal that we should think or keep in mind when designing the network is the manageability. For manageability means it is actually very important for the network admin, not for the normal users. The network should be manageable. Like for manageable means you should be able to log into your switches, routers remotely, and should be configurable from by connecting remotely. So for that, you should make sure to install and deploy only manageable devices within your network. And also to manageability is very important to find problems. Actually, to find problems, you can deploy monitoring tools. Today, as well, we are discussing about some monitoring tools like LibreNMS, and using those tools, we can monitor the link usages and like things, so that we can find problems, whether there's an attack happens, or whether the linkage congestion, so whether some network loops happen. So any problem, using monitoring tools, whether some devices are down, or we can monitor them using, we can find those things using monitoring tools. Next design goal we are looking for is the scalability. Scalability means when network, when the new users, so come to your institute, your institute grow, and you need to be able to provide them with the network connections. So you should always try to design the network so that it can be easily scalable, that is easily extended, so that so your network architecture should be very scalable. This actually a very simple thing about. I will talk about some network devices. Maybe because very new people are coming to this workshop. We thought of doing some basic presentations. First is the hub. Actually, the hub is even I talk very some nowadays some not accepted or deprecated device because hub is hub has a, if we connect devices to hub, it has a single collision domain. Single collision domains means any network congestion can happen to connect to that device. So the devices connected to the hub will have slow internet and feel like that way. Also, it has some risk since the hub always broadcast send packets to all the devices connected to it. It can be a very security issue because one device send the another device to another device some traffic. So other devices connected to the hub can monitor those information. So hubs are not recommended to use nowadays. Actually, I'm here just mentioning it because until recent time we used to use it. And next thing is the switch. Switch mean lay actually it lay 2 device, but it has also a variation of layer 3 multi-layer, that is a multi-layer switch. So there are 2 types of switches, layer 2 switch and layer 3 switch. Switches are actually deployed in LANs or local area networks. So actually this is the most widely used device in campus networks or any corporate networks. These switches are mostly deployed in edge level. That means the level closer to user. That means user connected devices. The user devices are directly connected to the switches. Next device is the router. Router actually in your network, I'm sure that only maybe only the learn provided router is there. Router is mostly used as the border device for your network, that is for accessing the internet or network service provider. You just use your router. So next device is the firewall. Firewall, we normally deploy firewall inline between the router and your core network, core devices, for protecting your network and do netting and like doing things like that. Next, we will see about the differences, or we are going to compare the router and layer 3 switch, because they are because those have very close relationship as well, and many differences. Let's see about differences of router versus layer 3 switch. Actually, router and layer 3 switch both are capable of routing. So where we use both the router and layer 3 device in our in our network. But those two has many differences, and they are made for different purposes. Actually, when we are talking about the scope, we are using router for WAN connections, like internet or other remote office connections, for data center connectivity, like that. So yeah, in contrast, the layer 3 switch we use for within the LAN network, maybe in office or data center campus, we use it within the LAN network. About the key functionality of router. Router actually route the traffic between across different WAN wide area networks, and router normally layer 3 switch normally route through the subnet within the network, or route through the VLAN within the campus LAN. So for inter-VLAN routing, we are using layer 3 switch. And router is actually router supports many technologies for ISP networks, for very distant network, like MPLS and VPN services like point-to-point network. But layer 3 switch does not support them, because they are not made for ISP WAN connections. And router supports technologies like that means router supports net. You know, net means network address translation. So we can in net we actually translate public address into private addresses and vice versa. And for firewall, and also router has capability to firewall your network. Actually, we recommend if you can have a different separate firewall for firewalling, otherwise using your firewall within your router. And also router support some tunneling technologies like tunneling means some encapsulation technology, that is in tunneling we encapsulate protocol within the protocol, like IP6 IP4 tunneling. We encapsulate IPv6 traffic within IPv4 network, so that we can transfer, or we can transport IPv6 v6 traffic through IPv4 capable routers. Also, routers support IPsec. Actually, that is some encryption protocols. These type of technologies are not supported in layer 3 switch. When we talk about routing table or routing table size, actually routers are made for solely made for routing, so it should have a bigger routing table because they are connected to internet edge, and they are using protocols like BGP things. So BGP has many thousands of routing entries. So in order to cater those number of routing entries, you should have a bigger routing table. In compared to router, layer 3 switch have a smaller routing table because it is only you taking care of routing of VLANs or subnet within your network. Then the forwarding decision. Forwarding means traffic forwarding a packet from source to destination or next available home. So when doing that, the router uses software or its operating system. So in contrast, layer 3 switch use actually hardware called ASICs. So actually, as you may know, hardware is always faster than software. So because software run on hardware, and so forwarding. When we talk about forwarding, the layer 3 switch take precedence, and it is very faster. Then about example of routers, actually there are many tens of vendors of switches and routers. I'm not talking about this. Here is a list of Cisco routers and switches. Next attribute is the interface support. Router support the WAN technologies, and also it should support the WAN port types. So like it supports like interfaces like SONET, CNN, T1. These are actually WAN technologies. SONET is fiber optic based technology. In contrast, actually, L3 switch does not support them because it is meant to be inside the network. In general, both devices support fiber and copper media for net connectivity. When we talk about throughput, throughput means actual data rate. Throughput is higher in layer 3 switch, and it is lower in router. So same with the switching capacity, as layer 3 switch has a higher switching capacity than the router. And about the cost, router has a higher cost, and layer switch has a lower cost. Actually, layer 2 switch is lower than the layer cost is lower than the layer 3 switch. About the port density, router has by default has a low port density. That the port density means number of ports supported by router. So as I have seen, the routers have few ports, maybe 3 to 4 ports, like. But layer 3 switches, like normal switches, it supports ports like 24, 48, likewise. So because within the LAN, many other layer 2 switches and devices are connected to layer 3 switch. So that's why layer 3 switch has many ports. Next, we will talk about the differences or features about layer 2 and layer 3 switch. Basic function of layer 2 switch is to do switching only. Switching means actually operate on layer 2 network, or we call it also Ethernet. Only it operates on Ethernet. And in contrast, layer 3 switch can operate on both layer 2 and layer 3. It supports some routing protocols, some few routing protocols. And talk about switching speed, layer 2 switch has high speed switching. It's only actually it's only made for switching, so that's fast. And layer 3 switch, switching speed is less than layer 2 switch. And addresses used in layer 2 switch communication are MAC addresses. As you know, within layer 2, in layer 2 devices communicate through MAC addresses, and but in layer 3 switch, it can use both the MAC and IP addresses because it supports layer 3 functionality. Next, we'll talk about cabling that we can use to build our network. First, we'll see about copper cables. We call it also twisted pair cables. Actually, from history, it comes from Cat3 to now we have Cat 7A and Cat 6A in development. So here we see about how the Cat cable are constructed, or how it is made, and bandwidth. So it's supported, and maximum data rate it supports, and maximum length that particular data rate can be transported, and about the applications that that cables are applicable for. But actually, Cat3 is a very, very old cable. I think Cat3 and Cat4, anyone knows, maybe some of you, most of you have not touched them. And actually, they have very low bandwidth. Here, bandwidth is actually not Mbps or some data rate. Bandwidth actually means some the frequency that cable supports. Here, as you can see the values, Cat3 are using token ring networks and 10 basically Ethernet networks. The token ring and actually Ethernet are two different layer 2 technologies. Then Cat4 is used in token ring, and Cat5 is using, it has some 100 Mbps capacity. Actually, all Cat3, Cat4, and Cat5 are UTP. UTP means untwisted pair, unshielded twisted pair cables. That means it has 4 pairs twisted. It has 4 twisted pairs. That means altogether 8 cables. They are not anyway shielded. That's why it is called unshielded. They are just wrapped within a plastic cover. So, and it supports, the Cat5 supports 100 Mbps. It can transport 100 Mbps for a length of 100 meters. It supports 100 base, 100 gigabase, 100 base, 100 base technology, and 1 gigabase technology. So Cat5 is actually more advanced. It has more cable constructions. It comes with more variations. It comes with foil foil unshielded twisted pair. That means all 4 pairs are foil with the aluminium foil, wrapped with the aluminium foil, and it also comes with the UFTP. UFTP means unshielded foil twisted pair. That means each individual pair is wrapped with the aluminium foil. So altogether there are 4 foils, and there is no overall foiling, only plastic wrapping. So that supports somewhat higher bandwidth and some supports 2.5 gigabits base technology. When we talk about Cat6, it is also more improved. It also supports FUTP and UFTP, and it supports data rate up to 10 Gbps, and it can be used in 5 Gbps and 10 gigabase technologies. So that means to connect 10 gigabit network, you can use Cat6. And also Cat6A is somewhat improved. It supports more bandwidth, 500 megahertz, and it comes with additional construction called SFTP screen foil twisted pair. That means it has a mesh, some wired mesh around the cable. So Cat7 actually supports as shown here, and supports 10 gigabit, 10 gigabase technology, and Cat7A supports also 10 gigabase technology. but they are improved by version. They are improved than the previous versions. And Cat 8, actually, I think it is still in some product development level likewise. Maybe some of the maybe recently in production level, they have it supports actually 25 and 40 gigabase technology. That is, it can be Cat 8 can be used in 40 gigabits, 40 Gbps networks. And next we will see about fiber optic cables. Actually, fiber optic cables have mainly has two different kind of fiber optic cables. One is multi-mode cables and other is single mode cables. The OM 1 to OM 5 are multi-mode cables, and OS1 and OS2 are single mode. Multi-mode cables are used to you actually are recommended to use within a building, and single mode cables are recommended to use outside the building for longer distances. Actually, the now trending is the now current trending is using single mode cables where everywhere possible, because it's much faster. Its supported capacity is higher. So if you can afford a single mode cable, use it everywhere within the building and outside building area. And you can see there's a fiber optic diameter core within these cables. As you can see, the core diameter is very in micrometer, very small diameter, like thin of thickness, has a thickness maybe there lower than here, and these supports actually it supports you can see 1 GB and 10 GB, 40 GB and 100 GB speeds with different distances. Normally OM and OM2 cables are not supported in high speeds like 40 and 100 MB, 100 Gbps, but OM4, OM3, OM4 and OM5 supports those speeds with the less distance, like 100 meters. And about single mode cables, OS1 is not recommended or not to use in 40 Gbps and 100 Gbps network. OS2 only recommended to use in those networks. So OS2 can transfer longer distance than OS1 cables, like 10 kilometer in contrast with the 2 kilometer. So when the cable is better, cable version is higher, it can transfer some speed for a longer distance. Now we are going to look for the campus network design rules. That means rules that we should adhere when we are designing a campus network. When it is recommend, actually when designing a network, we recommend to follow a network design model or network design architecture here we are recommending the layered network design, or we call it three-layer network design. And as you can see, we will discuss these topics in coming slides. And this is actually called the layered hierarchical network design. This has three layers: core layer, and distribution layer, and access layer. And this model is this design is modular because why this modular? This has three different layers with three different functions. So that's why it is called modular, and it is hierarchical. First, the core layer. Core layer is actually should be very reliable or resilient. That means should be in a failure situation, it should automatically recover within an acceptable time frame. And core devices are not always change, and not always configurations are not always change. And it has a few features, and it should have high link speed and high CPU capacity, because all the traffic coming from the user goes through this core layer. And next is the distribution layer. Distribution layer is the actually interconnection between the access and the core layer. So it aggregates the all access layer traffic. All the access layer switches are, layer 2 switches are connected to distribution layer switches. Normally distribution layer deploy the L3 switches, multi-layer switches. We rarely use layer 2 switches in distribution layer. And distribution layer also should have the redundancy. That means if some it should have device redundancy. That means multiple some device should be connected to multiple devices for failover. And the third layer is access layer. That is the edge layer that user directly connected to. That means in access layer we deploy L2 switches. To those L2 switches, users are directly connected, and in the access layer, the port density should be high because users are directly connected to it. So every user should have a single port at least. And the affordability and security features and should be high in access layer switches. And normally access layer switches are removed and added, and configuration changes are done more frequently than other layer switches. This is the diagram of the layered network design. This is the simple view. Later we discuss about the redundant view. As you can see here, if you can see in the middle, you can see the core layer, and next down there you can see the distribution layer. Normally in our campus network, in core layer we can have a layer 3 switch. Also you can have a router, but layer 3 switch is recommended for a campus network. and also in distribution layer, you can see layer switches, and down there is the access layer. Access layer is the where users are directly connected. In access layer, normally we deploy layer 2 switches only. So also you can see the access number of devices in the access layer are higher, and next in the distribution layer. So the connectivity of the diagram is like this. So devices are like this, and next the core switch or core layer switch is connected to the border router. Yeah. In case of your network, it is connected to the LAN provided access router. Normally, there is a firewall between this router and the core switch. So I haven't shown it here. And the network border router connected to the internet service provider for internet access. This is the redundant model of it. And as you can see, each device is connected to two or more upper layer devices. As you can see, these down access layer switches are connected to two above distribution layer switches. If one distribution layer switch goes down, the traffic will go through the remaining distribution layer switch. Likewise, core layer also have device redundancy and link redundancy. So also you can see in core layer there's either channel for high speed connectivity and redundancy purpose. And so also you can have two routers in network border. Then you can also, if you wish, you can connect to multiple internet service provider like that. So both routers will connect to both internet service providers at the same time. So redundancy is the key for the resiliency and the high availability of your network. So if you can afford to purchase more devices, it is much better to go to redundant layer network design. We are talking about the campus network design rules. So the next rule I would like to discuss is the number of devices in the path and how they can be arranged, in which topology they can be arranged. Normally, it is advised to use star topology, we call it hub and spoke topology, everywhere as possible, and also use try to avoid daisy chain network. Daisy chain or cascaded network means device is connected to another device and like a chain. So when some intermediate network down get down or fail happens, the other devices, other switches connected to it won't have the network connectivity. So that's very bad habit or bad construction when you design a network. So this shows where the star topology normally used in your normally star topology normally deployed in your networks. Star topology means hub and spoke like arrangement, and as you can see in the above network architecture, in many locations as shown as circle. You can see the star topologies or hub and spoke topology. Next rule is to route near the core and switch at the edges. That means we should route traffic near the core. Normally we route traffic near the core. As well we route traffic at the distribution layer. So in distribution layer we route inter-VLAN traffic. So we use layer 3 switches or multi-layer switches at the distribution layer. So for that purpose, and we are just switching and at the edges or access layer, because access layer only operating layer 2 of the website module. Actually, routing has advantages. It creates subnets, and it limits the broadcast. As you have heard known earlier, the single Ethernet network or LAN have a single broadcast domain. So it is a good practice to always break down or divide this broadcast domain by subnetting. Normally we build a edge network within a building. So imagine this rectangular is shown here is a building. So it has the devices connect like this. Maybe these devices, these layer 2 switches are in different floors. This switch, or we call it aggregation or distribution switch, it mostly we prefer it to be the layer 3 switch. So all the switches down there, layer 2 switch down there connect to this distribution switch. If it has the redundancy, there may be two or more aggregation switches. Aggregation switch may be located in the maybe in the base floor or down in the floor, and maybe these layer 2 switches each are in each floor. So and this is a fiber optic cable that run to layer 3 device. So it is actually layer 3 device in most cases it is in the main server room. When you start a network, imagine you have a network. You have a network with small staff and a small space. Then or you start a create network in a new building. So only few people are working there for the moment. Then you will just buy a single switch and connect those computers to that switch, and you can connect that switch to core layer 3 device. So this is how we start it. We normally, when few users are there, we don't buy many switches. Then users comes to your building or your maybe your faculty or your department. You buy another switch and connect it like this in like in a star topology way. So you can connect, you then connect users to that. Likewise, you keep adding switches while you are adhering to the star topology, right? Likewise, now here is the access point also connected. Now now when you come into a situation like this, actually there are when there are close buildings, imagine like this, there are closely located 3 buildings, and one middle one is older building and new building is built in the left side, and likewise. So when that situation comes, you must always should avoid this like configuration, because you should not connect new building switches to adjacent building layer 2 switches. It is a very bad practice. You should always try to avoid this situation, because people may try to go to this this type of configuration due to the cost issues, like fiber laying issues. When the core main server room is far away, you don't have money, you don't receive the money to lay a fiber cable from the new build to the core layer 3 device. So you just try to connect it to the nearby building switch. So even that is cost effective, it is not always recommended, and it is best to avoid it at any cost. We previously talked about edge networks, that is access layer networks. Now it is about the core network. It is like this actually. Core layer 3 device is connected to other surrounding building or other surrounding networks. So imagine this single building has distribution switch and a few layer 2 switches as described earlier. So core layer 3 is connected like this. So and as I said earlier, you can use a router also for layer core device, but since layer 3 switch has many ports that can has a higher port density, it's better within a campus network if you can use for layer 3 device. The other reason is routers are actually high cost. Actually, routers can be accommodated with many ports, but the cost is the fact. Also, then core switch is layer 3 switch is connected to the border router like this, and also servers should be connected. The centralized servers should be connected to the core layer 3 device. Normally, core layer 3 device and servers are servers are located in a single server room. As said earlier, the server should be directly connected to the layer 3 device. core layer 3 device, and it should have always good power and air conditioning, because if it get fail for some reason, for heating or some power issue, then all the users in these buildings will not have internet access. Where to put firewalls? When we place a firewall, we place it always in line, or whether in routed mode or transparent mode, what you prefer. Normally we place it like this. We place it between the border router and the core layer 3 device. Science DMC. DMC is the actually demilitarized zone. Science DMC is some zone dedicated for zone created for scientific applications or hosting scientific servers. So normally we host this. Actually, the Science DMC is normally optimized for high performance computing and other scientific applications. It should be capable of this high volume of data transfers, and we bypass actually we are not connected through the firewall here, as you can see, because the firewalls are stateful, and it slow down the performance or slow down the data rate of the traffic. So that is not suitable for scientific application or high performance computer like this. So for campus networks, it is recommended to have a science DMC, because campuses are actually research institutes. So many applications may be deployed there. We will see the border router configurations. Normally, border router is the gateway for the outside world, and it may connect to one or more, two or more ISPs, one or two ISPs, and it may be connected to your friend. In a learn case, actually, in most cases your network is connected to the research and education network. That means here REN means in your network. In case of your network, it is learn. Normally, I don't think you are just directly connected to any other ISP like this. But this is some setup that is deployed in campus networks. So here in border router, you can do firewalling. It supports a small firewall, and it can support the network address translations. But it is recommended to have a separate physical or software firewall for firewalling and netting. When all the things are connected together, it comes like this. Actually, this is some different diagram. You may be confused. Think these these low-level networks are different buildings constituting different layer 2 and layer 3 switches. And so connected to the 4 layer 3 device in the middle. So servers are connected to this, and firewall is deployed in line with the border router and the 4 layer 3 device. And there is ISP and research and education network connected directly to the border router. Also, science DMCs are connected to directly to the border router. So that's what we all discussed here. So this is the complete setup. This is actually without this picture does not show the redundancy, but always you can deploy it with the redundant model. If you can afford to purchase multiple devices, you can deploy redundant devices as discussed earlier. So only thing is we have many another device in parallel and interconnect those devices with each other and connect with the upper layer devices. So wireless in campus. Normally nowadays people need wireless connections. They are not only looking for cable connections, because people are mobile and people go here and there. They need Wi-Fi connections. So this depicts the wireless deployed in the campus. As you can see, when deploying access point, we use the same layer 3 and layer 2 devices existing in the network. So we don't normally directly interconnect access point together. We don't normally interconnect wireless devices only, but we connect them to existing layer 2 switches. Here, as you can see, we can also have, as this red line shows, we can have wireless point-to-point links. Imagine that you have a remote location. Actually, it's very hard to lay down a fiber cable so that you can have a point-to-point directional wireless connection, so that you can have the internet at the remote location. So when authentication, talking about the authentication of the wireless network, normally we deploy authentication servers or authentication portal in the main server room near the core router. So all Wi-Fi devices connected to the access layer, access level should go through this shown the green path and connect with the that particular portal or authentication system, authentication gateway to authenticate with the Wi-Fi. Normally, there are, when we talk about wireless system in campus, we can have mainly two or three different wireless systems. The one we see nowadays is a wireless system with the controller. So there's a different controller that manage each access point. Imagine if you have a Aruba access point, there's a separate controller for Aruba controller for managing the access points. So those are logically connected like this, but not physically. Actually, physically, these access points are connected to the layer 2 switches, and control is in the main server room, and we create a virtual path through VLAN, VLAN tagging and VLAN trunking to the access point. That's how we create this logical path. And administrator can log into the controller and manage access point and other wireless properties like password and SSID things, and monitor the who are the clients connected and what's the bandwidth they are using like this. Other wireless design is actually wireless network is actually the controllerless or virtual controller based wireless network. When we can't afford when we don't have a physical wireless controller, we can, if the particular access point are supported with the virtual controller, we can arrange or connect devices like this actually, and we can use the virtual controller feature in these devices. So normally in that situation, when you connect to a IP address, that management IP address of a particular access point, we are normally directed to the virtual controller, that is virtual controller located in particular access point. So we can do the management of the wireless network like in previously, and so when imagine that selected the virtual controller is get down, so another access point will take over that virtual controller and will do the controlling of the wireless system. Now in your network, you can have multiple or you can have dual homing, or you can have multi-homing. You can have two or more internet service providers and other, you can, maybe you are connected to other networks. In case of Learn, we provide actually backup or secondary connection to some selected institute with higher bandwidth. So in that case, they can have two configurations. When they have dual homing, actually one institute currently have two institutes currently have this configuration, that is ISP. You have two ISPs normally. It is one is the upper ISP is SLT, and another one is a dialogue. So in case of Learn, they are connected to same access router. The two institutes have this setup currently, and they are connected to like this, and they have a failover setup. They don't have a load balancing setup. That means only primary connection is active at the moment, and when the primary goes down or disconnected, secondary connection will up. But not both the primary and secondary connections will not be used at the same time. So that is the current setup. So second setup, you can have actually some institute also have this setup. When we provide two connections, they both connections have access routers. So both access routers are connected to the institute firewall. So load balancing is done through the firewall. The disadvantage of this setup is they can only access the internet, but due to the routing issues, outsiders, that is using public internet, can't access the services like web service, email services, like these things within the institute due to the routing issues. So some institute have this setup. Actually, we hope to convert this setup in all of the institute that have dual homing. So the other DHCP server, normally you need a DHCP server if you have a larger network, because for a large number of users you can't manually assign IP addresses, or maybe users are not competent to configure the IP address at their computer. So it is recommended to have DHCP server. Normally, DHCP server should be centralized. It should be located in central location, that is in your main server. And if that's the case, you need to have DHCP relay for connecting DHCP relay within your intermediate routing level. That is, you need to configure DHCP relay within your layer 3 switch, or where layer 3 switch is the location where layer 3 routing happens. So in order for clients to get the IP address from DHCP, you need to configure DHCP relay at the gateway of the subnet, so that DHCP request from the client will be forwarded to the particular DHCP server at the main server room. So it's always better to have another DHCP server as a failover, so that you can secure the DHCP availability with redundancy. Then other essential service we need to have is DNS. DNS should be reliable. No DNS means no service, no internet. Actually, you may have internet network connectivity, but you won't have you won't be able to browse the internet, because there is no DNS resolution. So it is like DSCP server. It is recommended to deploy DNS server at a central location, and there are mainly two types of DNS servers. One is authoritative DNS server, and other is recursive DNS server. What you normally use is the recursive DNS server. What you normally configure at your laptop or computer is a recursive DNS server, and normally ISPs provide you with the recursive DNS server. Learn also provide you with the recursive DNS server. And authoritative DNS server actually is authoritative DNS server provide only information about your domains. Imagine some university has PDN University. Peradeniya University means let's take the Peradeniya University. It has a DNS. It has a domain pdn.ac.lk. So they have their own DNS server. They have their own authoritative DNS server. So it provides information about subdomains like web.pdn.ac.lk, lms.pdn.ac, such like that. It provides information about subdomains of the domain from that authoritative DNS server. Target audience is actually the internet users. That means outside users. When outside users access the internet, access your website, they will access your authoritative DNS server through a recursive DNS server and access that information and do name resolution and access your service. The recursive DNS service for all of the users. That means normally recursive DNS can be configured in your institute for resolution of all of the domain, not only your domain. So through recursive server, you can browse, you can get DNS resolution of all of the domain of the internet. But also it is normally can be combined, these authoritative and recursive features in the same DNS server. So that's about it. I think yeah, time is just 4 minutes remaining. If anything you want to ask me about anything about this presentation. We talk about here about the basic network design, network design goals, network design rules, and cabling. Devices should be interconnected, and what are the recommended architectures, network architectures that should be deployed in your campus. This presentation will be meaningful if you are very new to the networking. If you are just a beginner, otherwise, I know you know many things. In the afternoon, we'll see into IP addressing and subnetting, and we learn some theory. All actually introductory material. In the last hour actually of the day, we hope to start with setting up lab, actually do some presentations by Jitter. So if there's no concern from your side and no comments, I think it's now 12. So we are now next going to session 2, start session 2 at 1:30 and up to 4 p.m. So thank you for coming to and listen to the session. So I'm going to stop it here. Thank you again.